Hello, everyone. Audio is okay. Hi, my name is Fuad. I'm a software engineer at Nubank.
Hi, my name is Paulo. I'm currently a data scientist at Nubank also.
And we work on a team called Customer Support Design. And we're going to talk about a little bit of the work that we have been doing for the past couple of years. So for those who don't know Nubank, we're a fintech. Our main product is a credit card with zero fees, and you control it through a mobile app. So all the interaction with the credit card is completely digital. There is no paperwork or physical branches, things like that. And recently, about a year ago, more than a year ago, we launched our rewards program, which is basically a benefits program for the customers of the credit card. And late last year, I think in October, we have launched our third grade product, which is Nuconta. It's a payments account that you can use to pay your friends, pay bills, and it also serves as a kind of a savings account, so it generates interest on the money that you put in there. And we have reached a number of over 9 billion reais in transactions this year with Nuconta, so it's going really great. We have more than 4 million customers right now across all of these products. And our goal as a company is to fight complexity. Financial services are extremely complex beasts, so understanding credit cards, understanding interest, all that is really hard for people. Some people get it really easily. Some people don't even have bank accounts in Brazil, don't even know how to use a credit card in Brazil. So what we want to do is to break those products down with the simplest UX as possible to make complexity go away. But this is all the cool stuff, and if you know Nubank, you probably heard about that, right? But there's some other stuff that are not really popular and people don't really talk about. And one of these is we need a strong customer support product or a strong customer support team in order to market these products. Because, well, we're dealing with people's money, right? And you wouldn't put a money on a company that you don't trust. It's really important that when you have problems, when you're facing something that you don't really understand how it's working, that we can support you. We can help you. You can come to us with your questions and we can answer them. So we really need people to trust us. It's money. It's serious business, right? So we try really hard to provide a great UX for these products. We have designers, for example, product designers, working with us from the conception of a product to maintenance in production. So we take UX and UI really seriously. But sometimes that's not enough. Like I said, financial products are really complex. There's stuff that's completely out of our control. The way that the central bank in Brazil works, the way that other banks works, because we have to interact. We're working on an ecosystem. Like there are other banks that need to interface with us, and these banks might not provide great UX for their products. So we have to deal with that as well if we want to make the experience of our customers really great. So we need to support customers when adversities come into the game. Like I said, we have a complex domain. Imagine that third-party systems can fail. If you're transferring money out of your account to another account and that system is offline, like there's a problem with your transaction, the other bank is not going to give you a great UX to understand what's going on, so we're going to have to come in and explain to you what's going on. Customers need to negotiate their debt, for example. If you don't pay your bill on time, you're going to pay interest. And we want to make sure that you can pay us. So we need to provide a great UX for renegotiation, for example, for paying back your bill. But we need to guide you through the process. It's really complex for people to understand interest and how much money you're paying. Make sure that people don't feel like they are being ripped off, right? So we need to have a human touch and make sure that people feel comfortable when they're negotiating with us. People get scammed all the time. Have you ever had your card cloned, or someone made purchases using your card number and it wasn't you? This happens. It's really hard. We try really hard to avoid this. We have fraud prevention systems, but sometimes things just happen. Like bad things happen all the time. We have to deal with that. We have to be able to be resilient in relation to these problems. So now enter the customer support design squad. That's us. And our main goal as a team at Nubank, we have two main goals. Support customers, basically, it's in the name. We want to make sure that whenever you need help, you're going to have help as fast as possible and in a way that's as straightforward as possible. But we also take care of making sure that the people that work at Nubank can provide the help. So it doesn't matter if we can provide a great UX to the customer if our employees cannot serve you well. So we have to provide information and internal tools that are in the same level of our external UX. Our main product starts in the app. This is a screenshot of Nubank's app. If you tap this Me Ajuda button, it translates as help me. You are going to see an FAQ experience. So whatever problem that you help, you just need to ask for help. Tap that button, and you're going to have some static content like articles explaining answers to simple questions. Like, for example, this is a screenshot of I got a notification on my phone and I don't know what it is about. I didn't make a purchase, so I'm freaking out. Like, what should I do about it? Well, we're gonna explain to you step by step what to do. You should block your card. You should get in contact with us. You should make sure that you reissue your card so that you can keep using it and order a new one. And this is the current experience of what we call self-help, right? So self-help is basically making sure that the customer can solve the problems by themselves. Why do we believe that this is important? Because it's fast and it's effective. Like, if we can empower the customers to solve the problem on their own, that's the best experience, right? You don't have to wait on a line. You don't have to get in touch with another human being. It's on your hands. You can do the whole process yourself. But sometimes it's not enough. Like, there are some kind of problems that you cannot solve yourself. There are problems that you actually need, like, human help, so you have to get in contact with us. So we provide some buttons that you can use to get in contact with us. We provide today 3 channels for getting in contact. Chat, which is like an in-app chat session, email, regular email conversation, and phone. You can call us. We're not going to talk about phone here today because it's not that relevant for the purpose of this talk, but we're going to focus on chat and email. This is a diagram of the backend infrastructure for supporting email and chat contexts. So you can see that on the top we have a customer, it could be you, taps the Me Ajuda button, sees the FAQ, browses a little, doesn't find the answer to your problem, or you really have to get in contact with us. So you open a chat session, right? And we use Pusher, which is a popular tool for real-time interactions to implement the chat inside the app. And then the app will communicate with our backend service. This orange box here represents an AWS service, HTTP service as regular. And there's a chat gateway service that will take in messages and make sure that someone on the other side can see it. That's not really relevant for now, mind with me. On the bottom, we have a customer sending us an email. The process is kind of similar. You send us an email. We use Zendesk as a partner for customer support, so they process all of our incoming emails. And then Zendesk communicates with our email gateway service that works similarly with the chat, like translating information from the outside world to our internal systems. And you can see the third orange box here, which is called Queue. That's our service that's responsible for managing queues. What is a queue? Well, all these requests are coming in, like new chats, people tapping in the app, sending messages, people sending new emails. And we have developed an internal queue management system that's responsible for taking all of these things and turning into jobs in a queue, right? So that people on the other side, those other 2 folks there, so they can use a web app called Shuffle that consumes jobs from these queues. Like, they click a button and they take a chat. Like, it appears on their screen so they can answer you, or an email. They're going to read the email, like look up some data, and then answer you back.
Yeah, these people are called by us as experts. So we're going to hear that a lot on the talk.
Right, Xpeer is kind of a wordplay on experience and peers, because it's the person that's gonna talk to you as a friend and help you solve your problem. And some figures on our customer support. Xpeers represent 60% of Nubank's headcount. So like more than half of our employees are customer support people. They take phone calls, they reply to emails and chats every day. The team works 24/7 to ensure that you can trust us and that whatever time that you want to solve a problem, we're going to be there for you. We receive around 13K emails a day, 45K chat sessions are open, and 7K phone calls. Like I said, phone is not really our main communication channel, so I'm not focusing on it right now. But now imagine we have all these people solving people's customers' problems. How do we organize all this mess? Because it's a lot of people, lots of customers, like I said, more than 4 million. And there are questions of all sorts. There are simple questions about your bills, simple questions about the rewards program, but there are problems that are more complex, right? If your card got stolen or someone made a purchase on your card and you don't know exactly what's going on. So we divide to conquer. We use a squads model, organization model within Nubank. All of the company is divided within squads, and these squads kind of represent a map back to our financial systems domain, right? So this is a small list. I think there are 10 squads here, and these are the squads that deal with customer operation dailies. I think we're around 40, 45 squads total, but not all of them have to deal with customer-facing issues like customer support, for example. And we have like squads that deal with logistics, for example. If you order a new card, it's going to have to be shipped. So we have carriers who are going to transport your card. We have to integrate with Correios and post offices. So this squad is responsible for everything related to logistics, right? From issuing your card, for actually making a plastic thing that's going to your house and shipping and making sure that it gets there. And if they don't find you home, it's returned and then we can send you later. Things like that. And dealing with problems, like possible problems that can appear in this flow, you need to change your address because you typed it wrong. Or maybe we tried to deliver and you were not home and then you have to reschedule it. Things like that. Just examples of possible support inquiries that we receive. Another example of a squad is NuConta, which is our payments account. There's an entire team focused on solving problems about NuConta, right? And these problems could be simple questions about how is my investment returns calculated, or taxes, for example. Boleto payments, it's a topic that's really hot. Like people try to pay a bill and the banks that receive the money are not receiving. It takes a while, like delays for processing payments. So that makes people mad. Like I paid a bill and it took a while for it to show up or didn't show up at all. People get mad. So where's my money? Like it's not in my account. It's not where it should be. So they get in contact with us to solve these problems. And here is an image. It's like a zoomed in version of that diagram. And this is how we kind of organize our backend to support these multiple squads and to divide our workload in multiple teams. This is the orange box I mentioned before. The queue management system is called Proximo. It's a cute name we find. I'm going to explain that later. And it manages various queues. Like so, on top you could imagine it's the logistics queue. Like those messages there, you can think of chats or emails that are incoming. And they're ordered by priority that we calculate using some metadata about the jobs. On the bottom, you could think it's the NuConta queue, like, and they are in queuing these jobs that need to be made actioned by experts. This is why we call that system Proximo, because its function is to have a simple interface for experts to ask for a task to do. We don't want experts to have to decide like what's the most prioritized task I should be working on, or should I solve this issue first or that issue first. We want people to just tap a button on Shuffle, which is our internal tool, and be presented with the job they can work on, right? And how do we do that? Well, imagine there are many queues here color-coded, and they feed into Proximo, and experts just have to tap a button and say, I am able to answer questions or to answer support inquiries about these topics, like red, blue, or black, or green, or whatever. And we just have to make sure that we deliver one job to that expert to perform. And it has to be the highest priority, and it has to be the right thing. Because if we start delivering jobs that are not what this expert should be working on, then, well, he's not going to be able to action on it. He's probably going to have to transfer this to another team, and we're going to delay the actual support to the customer. We're going to relay the what we call first response time, right? Because we want to make sure that we can help you fast. So if there are many hops in the way, we keep you transferring from queue to queue. That's bad for the customer. It's bad for us because we waste time. So we want to make sure that experts, when they ask something to do, we give them the most priority task for them to do right now.
Yeah, but now we have a problem, right? We have a lot of queues, and we have to decide beforehand, before doing the job, what is the right queue for an email or for a chat. So we have a big problem in our hands, and we can simply put a person in front of it and makes the person route things before getting to the expert. But there's another solution. You can make rules. You know the system. I know the system. I have a rough notion about Nubank and how it works, so I can make rules to route emails or route chats. And at the end of the day, we could also let the users, the experts, correct the routing if necessary. The rules are not perfect, so one thing you should do is let the expert reroute things and correct your system. So this is a good way to prototype the routing system. It's fast to act, fast to write, and you can capture the performance. You can monitor this. You can see how well your rules perform, and after that, you can use them as benchmarks. So this is an example of a rule. We have a client that has a card in route, and we probably should route the email from that client to the logistics queue. So this is one example. Another one is a client that only has NuConta, only has payments account. So probably when they send a chat, they should end up in the NuConta's queue. So this is good, but it's not perfect. We can improve on that and use the fact that the experts reroute and correct the rules after seeing the email or the chat. So we start collecting this data, and after that, we can make a machine learning model that can route things automatically, and this machine learning model improves with time. Rules are static, but machine learning models, you can train them with new data and end up with a better system. And at the end of the day, you're still going to need rules to perform your job. For example, at the launch of NuConta, we didn't have at all any data about NuConta contacts. We don't have any email, any example of NuConta. So it's impossible to route these emails to the right queue. So we're going to still need the rules, so it's good that we could start with them at the first place. So how do we extract information from text? Like now we have this email, this text that the customer sent to us, and we don't know what queue it pertains. We could guess, we could make rules, but when you're performing machine learning, you want to represent the words in the text in a way that is meaningful, in a way that you can extract information about the problem. So one way to do that is TF-IDF. Another way, which is the one I show here. Another way is like bag of words. You represent the words like ones and zeros for each email and use this as information. But on TF-IDF, you can use the term frequency, the number of times a word appears on an email, and which it means that a word that appears very frequently in this email should probably be important. But it's not always the case. You have words like for and to and. So these words are not meaningful, but they're very common. So we have to account for that. And what we do is divide the TF, the term frequency, but by the document frequency. The number of times that a word appears in all emails. So if a word is very common on all emails, it probably doesn't mean anything. So this is how we account for text. And after that, we put this representation of the text on a training pipeline that you can see here. Here, you put the TF-IDF representations of that particular email. And when you're training, you start with this weights here, and you multiply them. And after that, you sum everything, and you transform this number, the sum, into a probability. For example, if you're trying to guess if the email is going to be no conta, this probability is just that. It's from 0 to 1, how probable is that this email is no conta. It should be to go to no conta's queue. So on training time, when you're training the system with a lot of data, you can compare this with the real queue that the job end, and measure the error and use this to recompute and update this weights here. So this is how we train a logistic regression to guess what the right queue is based on text. But it's maybe not enough. I mean, there's more to it than text, especially on chats. On chats, many people say, hi, hello, how are you? Good afternoon. And we don't know how to route those systems because the text is not meaningful. So we need the context from the customer. We need to know what the customer needs without him saying. So we also make a contextual model. And the idea behind it is that we encode some features about the user here. And we have things like how much does this guy owes us? Does he have Nuconta? How much money does he have on Nuconta? And does he have rewards, chargeback, or something like that? And we input this on a complex model called boosting to predict the right queue for this person. So now we have these two models that compete, one from the text and one from the contextual thing, the context of the user. And you can stack both models and combine them to make a good prediction. So it's simply like this. You insert the output of both models on another machine learning model here, but also a boosting, and you get the final guess, the final decision about the right queue for that email. So this is how we do it. After that, when you see the results, although this model is very simple, and you may be unimpressed by it, we guess correctly 85% of our emails and 75% of our chats. So this makes the whole system much more productive and much more effective, and the time to answer a question is reduced by a lot.
Yeah, and I mean, like, this is 75% of the time we get chats in the right queue, which means that these people, these customers, probably won't be redirected anywhere else. So the first people that actually sees that chat or the email will solve it. The other 25 and 15%, we're not really sure because sometimes we route to the wrong queue. But the question is so simple that the expert that got that chat will be able to answer it too. So the rate of answering a chat or an email on the first interaction is probably higher than this. I don't have the numbers, but like we know that some subjects, like general questions about the card, can be answered by anyone in the company, so the rate will be a little bit higher. Now, imagine that we are able to route all these people. We are making the system faster because people don't have to hop from one queue to the other, and experts don't have to manually guide you through the queues. Like, they don't have to work like bank clerks that listen to your problem and, okay, go to that cashier or that one. Like, the system learns that and is able to deliver like your problem to the right person. It's able to match, right? But still, the worst thing about being in a line is the wait. It makes it faster, but doesn't prevent you from waiting. And like I said, in the beginning, we want people to solve their problems as fast as possible and as straightforward as possible. But then we come to think, many of the problems that people, or many of the questions, many of the emails and chats that we receive from customers, they are really simple questions. Like, for example, for people that don't have the card and they apply to get a new card, they get denied sometimes because of credit score shenanigans. They're going to send us emails asking, hey, why didn't you get me a card? I don't owe money to anyone, like I'm unclean. Why don't you get me a card? And like these questions, although they're important, people are interested on our product. It's a shame that we can't offer them the product, but they're interested, like they want to engage. But there is really nothing we can do about that. Like we have a credit score approval system, and if it says that we can't give you a card, contacting us, sending us an email will not change that. Like the expert cannot click a button and then give you a card out of the blue. So those questions are really simple, and they deserve simple answers. Like, the answer is, we can't give you a card, there's nothing I can do. Or think about, like, if you want a credit limit raise, you can use the app to change your credit limit or ask for more money. Contacting us and sending us an email or opening a chat will not change that. We cannot change your credit limit from the back end. An expert cannot move a slider just to increase how much limit you have. So these contacts, they're not actionable on our side. There's nothing we can do. We can do is answer you that you can either solve the problem by yourself by asking for more limit, or waiting some more time using your card to make sure that we know you a little more. So then maybe next time we can give you a credit limit raise, right? So experts already use some kind of pre-baked responses to answer these simple questions, right? We call them macros because it's kind of like we have like templates that can be cherry-picked, and you can interpolate some data like the customer's name. Here I've got an example of one macro. I've translated this to English. We use it in Portuguese, obviously. And this is about credit limit. Like someone gets in contact, okay, I need more credit limit. Won't you give me why? Like, please explain. And then we can say, well, you're going to ask for a credit limit using the app. And then there's a step-by-step instruction of how you do it, right? This is the standard response for anyone that contacts us via email. This has two advantages. First, it's fast because the expert doesn't have to type this out. It's always going to be the same answer. And two, it's always going to be the same answer. So we make sure that expert 1 and expert 2 are aligned in the instructions, right? We make sure that this is standard procedure. But then think about it. Like, we have humans that are actually reading questions from customers. Like, we were able to guess the problem, so that job will probably be in the credit limit queue, something like that. But the expert still needs to read the question, select the macro that it needs to use, paste it on the Shuffle web app, and press enter, and then wait for the customer to reply back. That's not a nice task, right? Imagine yourself spending your entire day like copying and pasting and answering customers that come with this kind of questions to us. This is not a task that should be performed by humans. We thought that we could automate this and make the system more intelligent. So to make sure that first, you don't need to wait on a queue to get an answer for a simple response like this. And two, if you're waiting on the queue, you're probably competing with the other people that have like those hairy problems that actually need someone looking actively on it. So you're probably not doing really good for the system if you're coming to send emails and chats with these simple questions, right? So I think at the beginning of this year, we started working on a kind of an auto reply system that could be able to handle these tickets automatically.
Yeah, so we have now this tons of data of experts answering questions on email and using macros. So for each email, we have the macro that the expert used, if he used one. So now we can automate this in a very simple fashion, right? It's kind of the same thing of the routing system. I just need to guess the right macro. So we do basically the same thing. We organize the questions into buckets. Right here you have examples of how to recover a password, or waitlist email, or payment recognition. And these are very simple questions that can be automated, and we make sure that they can be. And so a text comes in the form of an email or a chat, and we have models in place to predict the probability of being of being in that buckets. So at the end of the day, you take these probabilities, at the end of the process, you take these probabilities and provide the users an answer. So this happens in seconds. While very simple, today this system is replying almost 10% of the emails correctly. So 10% of the emails on Nubank are replied automatically. So,
and if you think like 13K emails a day, that's 1.3K emails a day. You can multiply that by 30 to get an idea of how many emails we are auto-replying monthly. And it usually takes like around 3 to 5 minutes to answer an email or a chat. So you can think how much we are saving in terms of time and people that we have to hire to do these kinds of jobs.
Yeah. So for me, the take-home of this talk is not about the fancy machine learning things or the deep learning NIPS level and PhD stuff. For me, modeling is about establishing a modeling cycle early in the process, early in the game. So on all the systems here, we provided a way for the humans correct the guesses we made, and now we collect this data and make new guesses. And sometimes this seems very obvious, right? But sometimes my colleagues come to me and ask, oh, I have this fancy idea about the system, but I don't have the data. Oh, wait a second. If you don't have the data, why are you thinking about machine learning? You should think how to provide data and collect the data from your system and create this modeling cycle, this modeling loop early in the game.
Yeah, and as a software engineer, I can tell you that working with machine learning on a daily basis kind of changes the way you look at the systems that you make. It kind of forces you into a mindset of collecting as much data as possible and trying to label things that, like, maybe you don't have a concrete idea of what you want to do with this data, but maybe in the future there's someone with a great idea and says, oh, why don't we do that? And then you have like a huge data set that's labeled, and you can use that to train a machine learning model. So it forces us to think about, like we do with testing. Like, we write code and then we automatically think of testing it or documenting it. Working with machine learning makes us to collect data about the stuff that we're doing, logging events and timestamps, things like this.
Yeah, so also many people are afraid of using rules, but they're actually a way to jumpstart your system. You can use rules in a very good way. You can provide rules for solving a problem and generating value early in the game and jump-starting the cycle, this loop of modeling. So you start with simple rules, and now you have you create some value, like the routing system, and then you provide a way to gather data and monitor this, and just like the XPeers do to us. They provide a way to feedback from these decisions, and we use this data that we collect to replace the rules by a model. So there is no shame of using models in your system. You just have to find a way to, in some time in the future, you can replace this with machine learning. So this for me is the most important thing about creating intelligent systems.
Like I said, we have this system of auto-reply going on since, I think, a couple of months ago. It has been working for email only because the email interaction, the interaction model is kind of simpler. Like, you get a message and then you send back a message. If you think about chat interactions, it's kind of trickier because you get one message and maybe the customer just said like, hello, good morning, I have a problem, and it doesn't tell you anything about the problem. So it's kind of trickier to build a UX that's great to use with auto replies. And I want to make this point really clear. Like, we're not trying to implement kind of a chatbot, because when you think about chatbots, you think about natural language interpretation, and you're going to mechanically read a message and try to figure out using some kind of AI what message you should reply. Generalist systems in general, like, we don't want to do that. What we want to do is to be able to reply the first message of a chat and the first message only with some information that might help the customer. And if the customer is satisfied with the answer, they can simply close close the chat and that's it. And if they're not satisfied, they can say, okay, this answer does not help me. And then we're going to use the labeling to train the model. This answer is probably not the right one to this kind of problem. And we're going to be able to send the customer to probably a better like a person, a better agent to take care of that job. So we don't want to replace humans in the process. We think human contact with customers is extremely important. We have a award-winning customer support service. People really like talking to our customer support agents because they provide great and human contact, right? We don't want to get them out of the game. We just want to make sure that simple questions get simple answers as fast as possible and in a straightforward manner, right?
Yes, the same thing for the FAQ, right? You now have this list that is not personalized. The list doesn't know about you, but maybe collecting the data from the mobile app, you can order the entries of the FAQ or present a suggestion or something like that to improve the self-help experience.
Yeah, and maybe sometimes trying to proactively guess what kind of problem that customer will have in a couple of minutes or hours of days, right? We do have enough training that we have been running the company for 5 years, and the problems that we have now are not extremely new to us. So we have historical data that could be used in many ways to train novelty models that we haven't thought about yet. Like we're working every day on trying to improve this system.
Yeah, one of those things is dimensioning, how to hire people, how to schedule their work. We have tons of data, years of data of that, and we should leverage this to provide a smarter way to allocate the experts doing their work.
Yeah. So today we have like people that actually are responsible for looking at the volume of jobs in the queues to be done and kind of like manually rerouting people and saying, okay, this group of people will be working on that queue and this group of people will be working on the other one. We want to be able to automate that and have the system kind of like balance itself and make sure that we match the work, the amount of work to be done by the people working and consuming from the queue, right? And well, I think that's it. If you have any questions, we'll be around until the end of the day and tomorrow. We are hiring, so if you're interested in working for Nubank, you're interested in machine learning problems, or you're interested in other problems like financial systems in general, we're hiring, so come talk to us and we can give you more detail. Our building is like 1 block down from here, so it's really close.
So thank you for your time. It was a pleasure. Thank you.